So welcome everybody to this latest video on 162 Maths. In this video we'll be doing another topic test on the higher syllabus, but this time focusing on geometry and a measure review, which basically includes all the topics from geometry and measure, well, a selection of them. Now there will be a copy of the questions in the description below for you to download, have an attempt at before watching this video and going through the answers. So let's get started on this higher topic test on geometry and measure recap and review. So looking at question 1, we've got to use this grid where we've got the coordinates of A and B plotted, and it says that ABC is a isosceles triangle, circle the coordinates of C. Now for this, what we need to do is recognise that an isosceles triangle is where all the two sides are the same. And so from this, now obviously if this was a much bigger grid there'll be more and more options that we could pick, but I would say that if I just draw line like so. So you want to go for ones that actually do pick. Now personally I don't think they would allow coordinates that fall outside of the grid. So for example, if I imagine that C would be, so if A was the peak of the angle going this direction, then I could say what C would be over here. So you're probably looking at minus maybe 3 or 2 and 4. Now I personally think that they won't allow that. They're expecting your coordinate to be in the grid, otherwise they would make the grid a lot bigger in the question. So here our correct answer is going to be 3, 0. So if I just make a note of that, that is C, and obviously as you can see if I join those points up, it therefore makes my isosceles triangle. These two sides are the same. So moving on to question 2, it says that point B is translated by the vector of -2, -1 to the point D. What is the coordinates of D? So here, this means that -2 means it's moved 2 places to the left, and -1 means 1 place down. And so that's what I'd need to do. So with point B, I'm going to have to follow those instructions. So B is here, I'm moving it 2 to the left and 1 down, so then it becomes here, and so that then becomes 1, 3. So it's our second option. And then for question 3, it says point A is reflected through the line of y equals x to the point E. What is the coordinates of E? So for this, what I'm going to do is I'm just going to get rid of all these markings because it can be a little bit confusing. And what I'm focusing on is point A, was it? Yeah, point A. Now first things first, let's plot y equals x. So y equals x is this line here, which I should really have drawn with a ruler. And if point A is here, I'm drawing a perpendicular line, a perpendicular line from the reflection line, so it's half a square, so that half a square is going to be there, even though the line doesn't actually show it should be like that. And so the coordinate of D is going to be, and I don't know why I'm doing that, it's just to make it a little bit neater. And so this point here is going to be D, and what's this coordinate? Well, it's 2, 1. And that's our fourth option. So moving on to question 4, it says describe the single transformation that maps A onto B. Now with these questions, it's really important that first of all you establish which one is the old shape and which one is the new shape. So reading the question carefully, A is the old shape, B is the new shape. Now using a bit of common sense, you should be able to spot now the 4 transformations you've got to choose from are rotation, reflection, translation and enlargement. Now as you can see that A has physically changed shape from B, so therefore it is going to be an enlargement. And that should be your very first thing you do, is basically pick which transformation it's going to be. Now this is worth, it doesn't actually say how many marks it's worth, or it's worth 3 marks. So what I then need to do is go into the 2 criteria of what I need to mention when I describe an enlargement, and that is going to be the scale factor and also a centre of enlargement. So for this you can see now in terms of the scale factor, I can see here that the scale factor has been half. So B is half the size of A, so it's going to be a half. Now it's not going to be minus a half because the orientation of B is exactly the same as B. It's not been flipped, so it's not going to be a minus a half. Some obviously people think that because you're getting smaller you tend to make it negative. That's not the case. Obviously a scale factor of less than 1 or between 0 and 1 makes the shape smaller. And then finally I just need to mention the center of enlargement. So for this what I need to do is get my ruler and basically join up at least 2 corresponding points. So let me just pick a different color. Let's get the ruler back up. And what you're doing is just joining 2. It's going to be extremely awkward doing it on the computer. And what you want to do is draw a projection line so it goes through 2 corresponding points. So there's one, and then another one. This one here. So, and do the same. Now hopefully the printing of your question is decent enough for it to fall nicely onto a point. So here my center of enlargement is going to be, so center of enlargement is going to be 1. If you want to call it COE, that should be fine, or just even write down the coordinate, that should be fine. But that will be, enlargement will be with 1 mark, scale factor of half is 1 mark, and the coordinate would be worth 1 mark. And if you missed out any of those, you would obviously therefore lose a mark. So moving on to question 5, it says the diagram shows a sector of a circle with a radius of 4. The perimeter of the sector is 12. Work out the angle of x. So for this, what we need to do is recognize the formulas. So here we've got an arc. Now the formula for an arc is theta over 360 times 2 pi r. And this length here is going to be 4. So what we've got is, if we know that theta is x and we know that r is 4, substituting those values into this formula, I get theta over 360 times, and it's going to be 8 pi equals, plus 4 plus 4, and that equals 12. So let's first of all get rid of the 4 plus 4, which is 8. So then what I've then got is theta over 360 times 8 pi equals, and it's going to be, I take away the 8, it's going to equal 4. So what I've then got is I need to then get rid of, I can get rid of the 360, so I've got 8 pi theta equals 4 times 360. Now if you wanted to divide by 8 pi, that should be absolutely fine, but basically theta over 360 times 8 pi is the same as 8 pi theta over 360. It's both the same thing. That's why I've taken the 360 first, but if you wanted to get rid of the 8 pi, that's absolutely fine as well, because obviously looking at BIDMAS, multiplying and dividing tends to fall on the same sort of plinth of the sort of BODMAS or BIDMAS triangle. So from this, what we then got is to work this out. So we then got 720, 1440. So then we've got 8 pi theta equals 1440, and then theta equals 1440 divided by 8 pi. Now when you are working this out, do make sure that your 8y is in brackets. Now the reason for that is because if you put it in your calculator as this, then what your calculator will do is do this, in which you'll end up with the wrong answer. You'll end up with like 568.5 or something along those lines. So here we get the correct answer, that theta equals, and it's 57.29577951, and so therefore if you round this up to 57.3 degrees, that's to 1 decimal place. So moving on to question 6, it says that a hemisphere of radius r is joined to a cone with the same radius. The slant height of the cone is 3r. Show that the combined volume is 2/3 pi r cubed, all multiplied by root 2 plus 1. So for this, let's have a look at what we need to do. So in terms of the volume of the combined shape, let's just write down the basics. So the volume of the shape is going to be equal to the volume of the hemisphere plus the volume of the cone. So what I need to do is work out those two shapes separately and add it together. Now the volume of a hemisphere is going to be 4/3 times pi times r cubed, and because it's a hemisphere, it's all going to be divided by 2, or we can multiply it by a half. So 4/3 times pi times r cubed times a half, because multiplying by a half or dividing by 2 is the same thing. Then looking at the volume of a cone, well, that's going to be 1/3 times r squared times the perpendicular h times pi. Now it's probably different, written in a different order. Let's just simplify that. So it's 1/3 pi r squared h, where h is the perpendicular height. So what I need to do first is work out what h is, and so therefore we need to use Pythagoras. So what I've got is I've got h squared equals, and it's going to be 3r squared minus r squared. So h squared equals 9r squared minus r squared. So h squared equals 8r squared. So h equals square root of 8r squared, or root 8r, or 2 root 2r. So now I've got all the components. What I can now do is go on to working out the volume of the entire shape. So here what we've got is the volume of the hemisphere. Let's do that first, in which I'm going to use this formula here. So either of those would be absolutely fine. So I've got 4/3 times pi r cubed multiplied by a half, and if I join all of those bits together, I get 4 pi r cubed over 3 times 2, which is 6, which then becomes 2 pi r cubed over 3. Then if I work out the volume of the cone, in which I'm going to use, let's go for this formula here, in which I've got 1/3 times pi times r squared times h, which is 2r root 2, and simplifying all of this, I get 2 pi r cubed over 3. Got a root 2 in there somewhere. There we go. It's probably not the neatest way of writing it, but that's basically the volume of a cone simplified. And so all that's left for me to do is to add these two boxes together. So what I've got is I've got volume of the shape equals, and let's go for, well, it doesn't really matter which one we go for, let's go for the volume of the cone first. So I've got 2 pi r cubed root 2 over 3 plus 2 pi r cubed over 3. Now from this, it's slowly looking like what they want me to show that it looks like, and I've got two options. So either from this I can either factorize this or expand the brackets, and it's entirely up to you which one you prefer to do. So for example, if I was to factorize this, I've taken out the common factors. Well, my common factors are 2/3 pi and r cubed. So to get the first one, all I need to do is multiply it by root 2, and to get the second one I just need to multiply that by 1, and therefore that equals basically 2/3 pi r cubed root 2 plus 1, and so that would be absolutely fine. But then if I expand the brackets, I would end up with this anyway. So again, something along those lines would be enough for you to get your 5 marks. So looking at question 7, it says that a large spring has a diameter of 15 centimeters, is made from 20 loops of steel cable, and steel cable costs £3.60 per meter. How many springs can be made for £1,000? Now straight away, one thing I do notice is that I've got a combination of units. So before we get started, and rather than me changing the units or thinking about units halfway through, let's work with so that we're working with just the same units. So 15 centimeters is equal to 0.15 meters, and that is the diameter of the spring. So first things first, let's work out the circumference of a spring. So circumference of one loop, and that's going to be 0.15 times pi, which for this sake I'm just going to simplify as 0.15 pi. Now I've got 20 of those loops, so I need to multiply that by 20, and that gives me that the total length needed, so total length for one spring is going to equal 0.15 times 20, which is 3, times pi, gives me 3. So that's how much meter is going to be needed for one spring. Now for this, if we then work out the cost of this, so the cost of one spring is going to be 3 pi times 3.60, and if I do that, so 3 pi multiplied by 3.6 equals, and it's going to be roughly around £33.93 per spring. So how many can I make in, let's say, well, or I could write it as 54 over 5 pi. Now what I then want to do is see how many I can make for 1,000. So I've just got to divide that answer from 1,000. So I've got 1,000 divided by either 54 pi over 5, or I can write 1,000 divided by 33.93, and if I do that, I get an answer of roughly, this one I get an answer of rounded up to 29.47, and if I did 1,000 divided by 54 over 5, calculator, I get roughly the same answer, in which then how many can I make? Well, I don't know why there's a pound sign there, so let's just get rid of that, but the correct answer you should have there is going to be 29. And then moving on to our last question, question 8, it says that is the angle A acute or obtuse? So acute, basically a reminder, is less than 90 degrees, and obtuse is where the angle is between 90 and 180. So let's have a look, and this is the angle that we then need to find. So for this, what I need to do is use the cosine formula. So I've got cos A equals, and it's going to be b squared plus c squared minus a squared, all divided by 2bc. So that's the formula I then need to use. So what I've got is I've got cos A equals, now labeling this triangle, this is going to be C, this is going to be A, sorry, no it isn't, I'm labeling it all wrong. This is going to be A, and this is going to be B, and this is going to be C. So substituting the values in, I get 5 squared plus 6 squared minus 7 squared, all divided by 2 times 5 times 6. Now if I type all that into my calculator, I get cos A equals, and typing it all in, 5 squared plus 6 squared minus 7 squared, and then all divided by 2 times 5 times 6, I get an answer of a fifth. Now from this, what I then need to do is do the inverse cos of 1/5, in which then I get an answer equals A, and so A equals 78.46 degrees, which is obviously acute. And there we go, and that is the final answer for this question.